Shoddy like a melody in my head. Hello, everyone. We're back again. Time for another nightly rant about, I don't know, the future. In general, it's going to be about whatever comes to my brain, but the future tends to be AI these days. But we'll take other detours. We're going to keep it classical today. Something that I'm actually pretty excited about. Someone put a paper called Idiosyncrasies in LLMs, large language models. And what do idiosyncrasies means? That means all the stupid cliches we're so sick of all the LLMs saying. Like when they say, "Ah, yes." I don't want to hear "ah, yes." I don't want to hear "delve." I don't want to hear "certainly." So here's a paper about it. Let's dive in, read, learn. I don't know. I haven't read this yet. Life is so great. We can learn every night. Abstract. In this work, we unveil and study idiosyncrasies in large language LLMs, unique patterns in their outputs that can be used to distinguish the models. To do so, we consider a simple classification task. Given a particular text output, the objective is to predict the source LLM that generates the text. So love this. I've actually been thinking about this for a while. I did do some early goofy tests of this, almost over a year ago, of saying, can you tell which model says what? Can you tell Claude versus GPT? Can you tell Midjourney versus DALL-E? Can you tell Luma versus Kling? I think it's very interesting that people say, I can tell if it's AI or it's not AI. Well, first of all, you're getting tricked all the time. We've already seen papers showing you're getting tricked all the time. The next step is, can you tell the different AIs from each other? Can you test their flavor, their idiosyncrasies? We evaluate the synthetic task across various groups of LLMs and find that simply fine-tuning existing text embedding models on LLM-generated text yields excellent classification accuracy. Notably, we achieved 97.1% accuracy on held-out validation data in the 5-way classification problem involving ChatGPT, Claude, Grok, Gemini, and DeepSeek. Good. The last paper we read yesterday didn't have DeepSeek, didn't have Grok, didn't have Gemini. How can we discuss the results of this? We need all of them. Our further investigation reveals that these idiosyncrasies are rooted in word-level distributions. These patterns persist even when the texts are rewritten, translated, or summarized by an external LLM. Wow, the flavor of each GPT, even when being translated, is still being preserved in some textual way. Interesting. Additionally, we leverage LLM as judges to generate. I lost where I was at. Oh no. Oh God, this is so bad. Why can't even to generate detailed, open-ended descriptions of each model's idiosyncrasies. Finally, we discuss the broader implications of our findings, particularly for training on synthetic data and inferring model similarity. Code is available here at GitHub. We love any paper that includes the GitHub link this early on. First paragraph, GitHub link, thank you. One issue, one pull request. What's the issue? Release LLM response datasets on Hugging Face, open 2 days ago. Hi, I'm Niels. I work as part of the open source team at Hugging Face. I discovered your work. Dude, you seem cool AF. What's up, Niels? And that's all we have so far. In general, we have a transformer pi. We have classification. We have a general response pi. Let's take a look. 247 lines of code. Nothing. I read that instantly. A little bit longer. 200, not even longer. Less long. 218. Classification. 300. So we're looking at less than 1,000 lines of code right here. 3 Python files, a license, a README, and that's everything we need. Oh, this world is so beautiful. It's so simple. I'm reading a paper, and the paper, it's only 1,000 lines of Python code. This is the official code for it, and that's what this transform classification generate response does. And it's funny because some of this stuff remove special characters, not even that advanced. So we might dive in the code at the end, but let's keep working through the paper. Introduction. As the adoption of generative models such as LLMs accelerates, it becomes increasingly important to understand the origin and provenance of such generated content. While a great deal of past work has focused on the classification of human-written and AI-written content, there's been little work on classifying between content generated by different LLMs. What's the difference between Claude versus OpenAI? Either between the outputs of entirely different models or between those different variants of the same model family. What does 4.0 look like versus 0.1 versus 0.3? What is this lettering numbering scheme? If possible, the ability to distinguish between source models in this manner would be valuable for a number of applications. It could shed light on the relative uptake of different LLMs beyond what is reported by individual companies and on the nature of data used to build different models. Additionally, it could offer insights into what features the output generation are most unique to each LLM. For me, what I would like to do is say, if any particular response comes to me and it says it is guaranteed it's coming from one of these LLMs, then I know I don't care about that response because we are saying that response is AI. Not just AI, but it's so idiosyncrasy. That's not a word. It's so much this one model that we know it's a Claude response. That's bad. That's bad. Eliminate it. I don't want it. So I will use these same techniques to identify what is AI and what's not AI. But it's not just about if it's AI or not AI. It's if it's cliche Claude, get rid of it. Cliche ChatGPT, get rid of it. Cliche DeepSeek, get rid of it. Cliche Grok, get rid of it. In this paper, we investigate whether LLMs exhibit idiosyncrasies that enable their outputs to be reliably differentiated, drawing inspiration from recent studies on dataset bias in computer vision, which demonstrated that images from different large-scale vision datasets also... I need to read this one. I can't believe I didn't read this. This is why I love papers. These nerds are referencing other papers. And the paper, geez. I love that it goes to our citation, but I want to go to the actual paper itself. Where is it? Oh, these little jerks. So I click this. It says, here's a link. What did it highlight? I can't see. But it's one of these papers. Okay, I'll do it later. You jerks. There's definitely a paper out there that is about the same thing for images that is even more interesting to me. And I will find that. We'll read that next, you little jerks. But I'm not going to... Okay, so we consider a similar synthetic classification task to assess the separability of responses generated under different LLMs. Specifically, we sample a large number of text outputs from each LLM using the same set of prompts and then train a classifier to recognize which model generates a specific text. Figure 1 provides an overview of our framework. It shows examples for all the classics. We find that a classifier based upon simple fine-tuning text embeddings on LLM outputs is able to achieve remarkably high accuracy on this task. This indicates the clear presence of idiosyncrasies in LLMs. We found that the classifier wasn't that hard to build. It's doing great. I can tell OpenAI versus ChatGPT versus DeepSeek versus whatever easily. So the observation is highly robust over a large variety of LLM combinations. For instance, trained on a combined set of text from ChatGPT, Claude, Grok, Gemini, DeepSeek, a model can achieve 97% classification accuracy on the held-out validation data, compared to a 20% chance level guess within the same model family. We obtain a non-trivial 59% accuracy across 4 model sizes in Qwen 2.5 series. Whoa! You're saying that we got a bunch of model sizes. We're saying 1 billion parameters, 2 billion parameters, 420 billion parameters, 6,900 billion parameters. I can tell you which one is which. That's good. We observe several interesting properties of this task. When controlling the length and format of the output through prompt instructions, we still obtain high classification accuracy. Furthermore, for post-training LLMs, the classifier demonstrates non-trivial accuracy even with only the first few tokens of the generated text. However, when classifying generations from the same LLM, but using different sampling strategies, we achieve accuracy only slightly above the chance level. Interesting. In addition, we observe certain behaviors of this task that resemble those of standard text classification, where improvements in text embeddings and availability of larger training datasets lead to better classification performance. Okay, kind of understand. A little bit here. Okay, I'm going to do a little... Okay, we see we're at right here. This is page 2. Watch this. We're going to dip through a little bit, okay? So we got some other stuff. And... Okay, cool. Look at this. Idiosyncrasies, effective tasks, some information. Great. And then, wow. A lot of it are these type of... Look at this. Beautiful charts. Oh, God. Here's the chats. Here's the phrases. Oh, my God. They all say the. They all say and, but according. Llama loves according. And then Qwen, certainly. Ugh, if I catch you saying certainly. Title, not good. Absolutely not good. According, comprehensive. Based, we've lost the word based. Python, if you say Python, you're a bot. You're a bot. Here's kind of a little breakdown as well. Interesting. It's interesting looking at it this way. Okay, let's go back up top a little bit. So we've got this big chunk of references here. And we've got idiosyncrasies in large language models. So here you go. ChatGPT, certainly creating title based the according Claude. Here, the certainly. Certainly. Comprehensive. So certainly is done. Remove it from your vocabulary. If you're a human and you say certainly, you're an AI. You're a bot. I don't trust you. If you say it in an email and you send it to me and it says certainly, I don't trust you. You little bot. You little bot. Look what you did, you little bot. Okay, let's keep. Okay, I'm scrolling. We're doing this one a little bit differently, okay? So, main observations. We observe surprisingly high accuracies by neural networks to classify LLM outputs. So check this out right here. We've got these different models here. We've got accuracy right here. And this chart makes no sense to me. Here's the accuracy. Classification accuracies for various LLM combinations. Top results. Okay. These are for combinations. Chat APIs, instruct and base LLMs. Check marks denote the models included in each combination. Okay, so this is a chart of combinations and showing the accuracy over here. This is the world's worst way I've ever seen to present data. Okay, so if you want to see DeepSeek at this point, times GPT, 97.2. Oh my God, I've never found a worse way to show information, but okay, cool. So look at this. They're all very high. What's the highest here? 99.9. That's DeepSeek with Gemini. Whoa. That's hot damn. It's good. It's real nice. Let's keep going. Okay, concrete idiosyncrasies in LLMs. We show that modern neural networks can achieve excellent accuracies in classifying which LLM generates a given response. Here we leverage classical's text similarity metrics, Rogue 1, Rogue L, and the BERT score to quantify lexical differences between LLM outputs. We compute the mean F1 score, and I'm not talking racing, for each metric across all response pairs generated by any two different chat API models given the same response. For comparison, we also measure the similarity between responses sampled within the same model, as shown in Table 7. Responses from different LLMs exhibit lower text similarity than those from the same model. Yes, if you're from the same model, you sound similar, you look similar, of course. This stuff seems obvious, but guess what? We're confirming through science, through papers, through experiments that it actually is true. Text shuffling. To decouple the effects of words and letters from other factors, we remove special characters in LLM-generated responses, such as punctuations, markdown elements, and excessive white spaces. This ensures that each response consists solely of words separated by a white space. Additionally, we apply two shuffling strategies to pre-process text, word level and letter level shuffling. These transformations disrupt the natural order and force the classifier to learn patterns from raw text statistics. Really? Is that a better way to do things? That feels unintuitive to me, but I'm dumb. You're saying letter level shuffling is going to help me compare two sets of data in a more objective way, how similar they are? Okay. If you say so. Okay, we checked this out before. Idiosyncrasies. Okay, so results of our open-ended language analysis of ChatGPT, Claude, ChatGPT. ChatGPT features descriptive language, sophisticated markdown formatting, and in-depth details. Claude highlights straightforward tone, minimal structure, and summarized content. It's interesting because yesterday we read the paper about people trying to use multiple different models to make $1 million on Upwork doing either programming management tasks or programming actual coding tasks. And Claude beat ChatGPT. Specifically, it beat 4.0 and 0.1. And it's maybe because that it gives you more straightforward, to the point tone might help. This could be explained hey, these idiosyncrasies of the model is why it's not making more money. Maybe if you can adjust these things, you could just make more money. I don't know. Semantics, rewriting. One potential reason for high classification accuracy is the unique writing style, word choice, sentence structure of each LLM. To isolate this, we Leverage another LLM, 4.0 Mini, to rewrite LLM responses. Okay, cool. Use another model to obscure more what the models are saying to see if the models still are correct. Great. 1 million references. The world's biggest appendix of all time. Love that. Words we don't want to read. Response demonstrations. Just showing, hey, how do each one of them talk? Can you tell one of them? Actually, so a fun thing we should make is a little silly website that just asks a question, shows a response from each LLM. You try and guess which it is. If you guess which it is, you win something. That sounds like a fun little one-day project that we should try out ourselves. But for today, I think we're there. The key idea is that we all know you can tell which model is which. It's true. You actually study it. You can figure it out more detailed. Even if you combine models, you can apparently figure it out. How do we remove these things from models? Do we want to focus on removing these things from models? How much does a prompt impact these things? How much does RAG impact these things? There's more stuff to learn about this particular category and how it relates. But in general, it's confirming what a lot of us know, which is hilarious. Basically, can you tell it's Claude? Can you tell it's ChatGPT? I think we can, but we need a website to actually test it. So I'll make that website, or someone I know will make that website. If not, who cares? I'll be back tomorrow. More talks about something in the future, something AI. If you want to talk about something, leave a comment below. That's it. I don't even know what's going on.